Earth Systems 3209. Unit 3, Earth's Materials. References can be found in the textbook for this unit in Chapters 2, Chapter 3, Chapter 6, Chapter 7, and Appendix A and B in the curriculum guide. Unit 3, Topic 5.3. This topic will look at metamorphic environments, and in particular, the regional metamorphic environment. We will focus on describing the environment's location where regional metamorphism will occur. When we look at metamorphism, metamorphism literally means to change form. These changes take thousands to millions of years to complete. During this period of time, the change in minerals within the rock can flow in a solid state and can, on the atomic scale, change. Metamorphism most often occurs during one of two geologic events. First geologic event that could cause metamorphism would be mountain building. During mountain building, we see a change in a very wide area of rock, and this is called regional metamorphism. Also, metamorphism can occur when we have an intrusion of molten rock. When molten rock intrudes other rocks, it could actually pass up through and onto the surface, and the molten rock burns the rock that it comes in contact with. And for this reason, it is called or referred to as contact metamorphism. Text references on metamorphism can be seen in your textbook on pages 201 to 205. This presentation will focus on regional metamorphism. Regional metamorphism occurs where tectonic plates collide, mainly at ocean-continent collision boundaries. This type of environment experiences compressional forces, producing extensive mountain building. The greatest volume of metamorphic rocks are formed in this way and in this environment. This type of metamorphism is caused by two main conditions. We see extreme pressure caused by the compressional forces of tectonic plates when they collide, and we also see extreme heat due to magma intrusions, and the depth within the mountain basically increases temperature with depth. Both these conditions, extreme pressure and extreme heat, are dominant in mountain environments. When we look at regional metamorphism, two conditions are responsible for causing regional metamorphism. The first condition is pressure. Pressure on rocks within mountain environments is mainly caused by, number one, confining pressure, which is caused by the weight of the material above it, and also directional stress, which is caused by compressional forces as tectonic plates push against one another. If we look at the diagram to the right, we see that we have red arrows which indicate directional stress. This directional stress causes the sedimentary layers that you see in the diagram to be folded. Within the folded sedimentary layers, we have a lot of pressure, and this could cause the minerals to change, and also can cause the minerals to align themselves, which is indicated by the scratching on the diagram. So directional stresses are coming in a horizontal direction, whereas the minerals within the rocks will recrystallize and align themselves in a vertical direction. Also, confining pressure will be applied to the bottom layers. All the layers located above will create a lot of pressure on the bottom layers, therefore aiding in the process of changing the rock due to pressure. This pressure causes rocks to deform and flow as if they were plastic. The minerals within the rocks will recrystallize and reorganize to form metamorphic textures. Folding is a common feature found in rocks that have undergone regional metamorphism. And we can see in the diagram to the right the directional forces caused by collision of plate boundaries will cause rocks to fold. Second condition responsible for causing metamorphism, regional metamorphism within mountains, is heat. Heat involved in regional metamorphism within mountain environments is the result of two conditions. Number one, the geothermal gradient, which states that temperature increases 30 degrees Celsius approximately for every kilometer below the surface that you go. So as you go deeper within a mountain, temperatures will tend to increase by 30 degrees Celsius approximately per kilometer depth inside the mountain. This increase in heat will also promote metamorphism. The second cause of heat within a metamorphic mountain environment is the intrusion of hot molten rock called magma, which causes the surrounding rock that it comes in contact with to heat up, and as the heat from magma radiates outwards, it will change the resulting rock. So when we look at regional metamorphism, where does regional metamorphism occur? Two areas in which regional metamorphism occurs would be number one, in mountain building areas, and number two, subduction zones, which are located along collision boundaries. If we look at ocean-continent collision boundaries, this is an example of where subduction and mountain building can occur. A compressional environment resulting in increasing in pressure, and as the mountains are forming, increasing burial depth results in increasing temperatures. These conditions lead to the formation of metamorphic rock. So if you look at the diagram to the right, we see that an area that's located in the top diagram basically will be thousands of feet deep and several hundreds of miles wide. Once pressure is put on this area in a horizontal direction, compressional forces, the resulting area will start to deform. On the surface, we still see sedimentary rocks, and deep within the mountain, we tend to find metamorphic rock. The two factors that affect the internal portions of the collision boundary, where compressional forces are being applied, would be as deeper you go inside the collision boundary, the higher the temperature. Temperature will increase, and also the deeper you go within the collision boundary, pressure will increase. Therefore, the interior of a collision boundary will be open to high-grade metamorphism. And high-grade metamorphism is seen where you have collision boundaries, and also is prone to formation of regional metamorphism. So in conclusion, in areas of mountain building and subduction boundaries, we see a lot of compressional forces, and compressional forces and the depth beneath the surface are two conditions that are responsible for changing rocks to form high-grade metamorphic rock. These two concepts of deep within the mountain, farther depth within the mountain, and also the more pressure and heat from a collision boundary, is seen in this example. In this diagram, we see a subduction zone, where one tectonic plate subducts beneath another. As a result, the metamorphism is not occurring within the subduction zone, but it occurs within the mountain system. As you can see, as burial depth increases, so does the grade of metamorphism. So when we look at the diagram down below, we see the farther we travel inside of the collision boundary, the deeper and the hotter the temperature gets. In areas within the collision boundary, we see magma. This magma will provide the temperature, the high temperatures that's responsible for metamorphism, and also all of the layers located above would be responsible for the confining pressure. And this confining pressure will cause the conditions that are necessary for metamorphism to occur. So the deeper we go within a mountain, from the surface down to the deep interior of the mountain, we see the rock changing. Rocks that are found on the surface that are formed by low metamorphic conditions is a rock called shale. Shale is a sedimentary rock that when you put it under more heat and pressure, it can change. And in this case, it changes to slate. Slate, when put under more heat and pressure, will form a metamorphic rock called phyllite, which then, put under more heat and pressure, will form a rock called schist, and finally gneiss. So the farther we go down into the mountain's interior, the higher the grade of metamorphism, where we start with shale and we end with gneiss. Information on this topic is seen on page 204 in your text. Let's look at some examples. Example number 1 states, in which environment does regional metamorphism occur? So by what we looked at in the previous slides, regional metamorphism occurs when we have increase in heat and increase in temperature and increase in pressure. So both heat and pressure are two conditions necessary in order for regional metamorphism to occur, and both heat and pressure are found in mountain environments. Therefore, a mountain belt would be the best answer. So in which environment would regional metamorphism occur? It occurs in mountain regions. So C would be your answer. Example number 2 reads, explain the sequence from A through D that will occur in shale as it is buried deeper within a folded mountains at a continent-continent collision plate boundary. So if we look at the diagram to the right, we will notice that we have a continental plate colliding with a second continental plate. And in between the two continental plates at this collision boundary, there's a lot of sedimentary rock that gets folded up into mountains. As we go from the surface of the mountain down to the great depths within the mountain, we will see both pressure and temperature increasing. And as pressure and temperature increases, so does the grade of metamorphic rock. So our answer to this question focuses on shale is a classic sedimentary rock that is capable of being metamorphosed. As shale is buried deeper and deeper in the Earth's crust, heat and pressure also increases. Consequently, the degree of metamorphism will also increase. That is, we go from low-grade metamorphism at the surface to a higher-grade metamorphism within the mountain's interior. This produces a predictable sequence of rocks as follows. Shale is metamorphosed into slate at location A. Slate is then metamorphosed into phyllite at location B. With increasing burial, phyllite changes to schist at location C. And finally, at location D within the interior of the mountain, schist changes to the highest grade metamorphic rock called gneiss. So if we back up and look at the diagram, we see shale at the surface of the mountains at location A, which then changes to phyllite, and at B will change to, shale will form to slate at location A, which will then form phyllite at location B, And the deeper we go inside the mountain, the more heat and pressure it is exposed to, so therefore the higher the grade metamorphic rock. So phyllite will change to schist at location C, and finally it will form gneiss at location D, and that's deep within the mountain where the highest temperature and pressure conditions are experienced. So your turn. Take the time to complete the following question. You can pause your recording now to prepare your answer, and the answer to the question will follow. The question reads, contrast the conditions necessary for a rock to change by regional metamorphism compared to that of contact metamorphism. So reading the question, we need to contrast conditions necessary. So one thing that we need to look for are the conditions necessary for a rock to change by regional metamorphism as compared to contact metamorphism. So we're going to contrast contact metamorphism with regional metamorphism by identifying the conditions necessary for both types of metamorphism to occur. When we look at the answer, regional metamorphism will occur in mountainous environments where rocks are exposed to high heat from igneous intrusions and high pressure caused by both compressional forces and confining pressure by overlying sediments or overlying rock layers. So here we look at regional metamorphism, and we look at the two conditions of high heat from igneous intrusions and high pressure caused by compressional forces. In comparison, when we look at contact metamorphism can occur in any environment where a heat source, namely molten rock, causes the surrounding rock to change. Thus, contact metamorphism is directly related to a heat source and do not necessarily need pressure. Thus, in conclusion, regional metamorphism is caused by an area where you have high heat and high pressure, such as mountain areas, whereas contact metamorphism is caused by only heat. If you look at a mountain environment, mountain environments do have intrusions of magma chambers within the deep mountain. Therefore, a mountain environment could possess both types of metamorphism, regional metamorphism and contact metamorphism around the intrusions within a mountain. So mountainous environments, although prone to regional metamorphism, can also have contact metamorphism present as well. In summary, regional metamorphism forms in areas where you have high heat and high pressure, and is generally associated with mountain building and collision boundaries, such as subduction zones. During regional metamorphism, we generally form high grades of metamorphic rocks, such as gneiss and schist. So in conclusion, regional metamorphism form in high heat and pressure areas, generally referred to as mountain building areas or collision boundaries such as subduction zones, and they form high-grade metamorphic rocks such as schist and gneiss.